Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Asyraf Basysyar bin Amizon, and I am Part 8 student of School of Mechanical Engineering from College of Engineering at UITM Shah Alam. First and foremost, I want to welcome my panel, Associate Professor Ahmad Kamil bin Hussein and Insinyur Dr. Wan Emri bin Wan Abdul Rahman. Not to forget that I want to give my big reward to my supervisor, Professional Technologies, Muhammad Fauzi bin Osman, and my co-supervisor, Dr. Muhammad Hanif bin Muhammad Namli, for guiding me from the early semester. First of all, about my project, I want to design and fabricate the sprayer system that can be attached to the existing drone, and with the control drone we can spray the roof of the house. What is the objective of this project? As I mentioned earlier, to design and fabricate the sprayer system and then attach it to the drone so that we can control the drone and the sprayer system also to clean the roof of a house using high pressure technique. Now, I will explain about scope of work of my final year project. First of all, I want to develop a sprayer system which consists of a sub-component such as pump design to produce high pressure water, tank design to store water in safe condition, and sprayer system which include the structure to get a strong climb with the drone and support at the high altitude. My project methodology begins with verify the parameter needed, such as if we need a high pressure, what type of DC motor we need. So I will model the shape in CATIA based on the DC motor survey. And then I will check again. Did the DC motor is suitable to assemble with the part that I have modeling? And I also must make the simulation to know the durability of the part that I have modeled. And next, I can go to the 3D printing process, which I need to hire a service of a shop. And then after 3D printing, I will assemble the part that I have print and check whether it can function properly or we need some more improvement. Next, I will talk about the type of drone that I have choose to assemble with my sprayer system. The name of the drone is DJI S900. This model can be checked at the GrabCAD. It is a free and open software and doesn't need any cost and permission. And now is the model of my sprayer system. Actually, it consists of 4 sub-assembly, that is tank assembly, that is blue color, base assembly, that is green color, leg assembly, that is yellow color, and pump assembly, that is red color. After that, I will talk about the improvement of design from the early stage to the final design. This is one of the early stage where the drone landing skid have equal height to sprayer system base. When we include the total height of the sprayer system, it will clash with the bottom part of the drone. So we must improvise this design. As we can see in the figure 5, it shows isometric modeling of the drone that have already attached with the design 1 of the sprayer system. We can see in clearly the drone landing skid, that is the bottom part of the drone that touch the ground, and the base of the sprayer system having equal height. As we can see, this is the next design that I have modified. We can see the leg structure is fully solid, where it is too heavy for the drone to carry. Therefore, we need to modify to become a better design. And lastly, this is the final design of the leg structure. As you can see in figure 7, the design is quite light, so the drone can carry it, and it also have a good strong connection of bolt, so that it is not easy to break during the flight. Next, we go to the analysis of the sprayer system. The part choose to be analyzed is tank and its base. This is result of simulation of von Mises stress on the tank base part. Since the tank is contain water with a volume of 600 milliliter, it already 0.6 kilogram, and sum up with the total weight of the tank and the lid, so it will cause such pressure on the tank base. As we can see, the result of the simulation, the color is blue and green, so it doesn't reach the yellow and red yet. The second part that choose to be analyzed is drone landing skid. This is the bottom part of the drone, where without a sprayer system, the drone, this part will touch the ground first. So this part will attach with the sprayer system. We must identify whether it can support, it can hold the sprayer system with such weight. And this is the result of the simulation of von Mises stress on the drone landing skid. As you can see, the color is blue and yellow. It is quite critical, where it just one level below the red, so that we need to improve the quality on material of this structure or modify on the design. The final part that choose to be analyzed is the leg structure of the sprayer system. The leg structure consists of three main parts. That is upper part, yellow color as you can see in the figure 12, and center part, that is orange color, and bottom part that is red color. And next, figure 13 show the upper part simulation of von Mises stress of the leg structure of the sprayer system. As we can see, the color present is blue and green, which it is quite safe. The pressure applied is calculated based on the weight of the sprayer system is divided by 4. This is because there is 4 legs of the sprayer system. And now, same as the upper part, this also shows a safe condition of the part when we apply the weight of the sprayer system. And the bottom part of the leg structure of the sprayer system show different result from the upper and center part. As we can see at the big hollow at the bottom part of this part, there is the red color. This is because this region contact directly with the weight of the sprayer system. So the direct transmit force is produce more pressure than the indirect contact force. As we finish the simulation on the critical part, we have to know why the critical part simulation show a safe condition. First of all, we apply the pressure on each critical part based on the weight of the sprayer system. As you can see on the technical report, the weight of the sprayer system is 3.04 kilogram, which consists of weight of the water, weight of the sprayer system, 3D printed part, and include the assembled components such as screw. And we apply the pressure with different weight on each individual part, such as for each landing skid, we only apply half of the weight of the sprayer system. This is because there is 2 landing skid that hold the sprayer system. Also, same case with the leg structure, we divide by 4 from the total weight of the sprayer system because there is 4 leg structure that hold the weight of the sprayer system. As the conclusion, there are some parts that are already print, such as pump part. We can see in the figure there is pump casing, pump impeller, and DC motor casing. The progress of this project is already finished on the structural design. It includes pump design, tank design, and the structural design of the sprayer system. Okay, that's all from me. Thank you.